Alright, so this is our third video in electron arrangements or electron configurations. In today's video, I'm going to teach you a shortcut, a method to do electron configurations that makes them just a little bit easier than it was before. And to see this, let's take a look at argon. Here we have argon with 18 electrons, and here is argon's electron configuration. So what I want to take a look at is actually potassium, which has one more electron than argon. So, whoops, let's do it in black. So potassium's electron configuration will be this. Right? It's one more electron, and that electron goes into the fourth energy level, into the S sublevel. And what's interesting, though, is if you look at these, you might see that they have a lot in common. We've talked about this. What they have in common are the first 18 electrons are exactly the same. And so it turns out that this first 18 electrons, the noble gas, is what is called the kernel of an atom. It's the innermost electron. So for potassium, the kernel is here, because those electrons aren't exposed to the outside world. They're not the valence electrons. Potassium's valence electron here, the 4s1 electron, is the important electron, because it's the one that interacts with other atoms. It's the one that undergoes changes. It'll be shared with other atoms. Rarely do the inner atoms or the inner electrons ever do anything exciting. They just they're there. And so what we can do with this inner set of electrons, we could rewrite potassium's electron arrangement like this. Where we represent the kernel as the noble gas preceding, the noble gas in the row preceding the element, and then we write on the valence electrons. So let's try this with a different element. So here we have the periodic table. So let's pick, let's get the pen, and let's do, oh, what the heck, we'll do rhenium right here, 45. So rhenium. Now, I could write out the first 45 electrons, but using our shortcut with rhenium, I'm going to find rhenium, I'm going to go to the row above it, and I'm going to find the noble gas, krypton. So when I write rhenium's electron configuration, I'm not going to write the first 36 electrons. I'm just going to write krypton. And now I go down here to the fifth row. So this is 5s1, 5s2. And then remembering that the D sublevel is one less, the principal number is one less than the row that it's in. This is 4D. So 41, 2, 3, 4, 5, 6, 7. So rhenium would be 4D7. And that's it. That's rhenium. And in fact, alright, so let's try this with one more. Get rid of rhenium's electron configuration. And let's do, let's go down and do tellurium here. Okay? So we're doing tellurium. And so when I write the electron configuration, go to the row above, noble gas is krypton, so the kernel, Ke, when I say kernel, I'm saying this. Whoops. The kernel, not like Colonel Sanders, but kernel like a popcorn kernel. So the kernel is krypton, and then we're going to have, as we go across, we're going to have 5s2. And then we're going to all the way across the 4D, so 4D10. And then this is 5P, 1, 2, 3, 4. So 5p4. So there is tellurium. Okay, in the next video, in our last video on electron arrangements, we'll talk about some weirdness when doing electron configurations. We'll talk about how to do the F block elements, and we'll do a couple challenge ones.